Hi and welcome. So this time around I got a couple quick customer projects. The first one is this mandrel needs to be turned down to support another piece made out of cold rolled right here, and this piece will sit on top, and one end of it will fit over this mandrel and the other end will be sized so that these pieces can sit on top of it, and they're held in place to have further operations done on them. So they're basically held in place on top of the piece that sits on this guy, and apparently this mandrel can be used for more than one thing. So it's pretty straightforward. Let's just get started. Next up, we need to turn this diameter down to 0.472 for a depth of 0.276. Trying to see how close I could hit 500 on the money. 1.2 thousandths over. I dialed in the exact amount, so that's interesting. So we're going to take, it's actually 29 thousandths, so we're going to take 28, and that should leave a thousandths over. So we're looking for 0.472, and it went 1,000th over. Like that's really good. I was shooting for 1,000th over, 1,000th over. And that should be that part done. Next up, we're going to face this part for starters. We take 30 millimeters, well, a little more than 30 millimeters of it down to 20 millimeters, or 0.787. So I think the outside diameter of this guy is already over an inch. We need to take it to under an inch. We're looking for 0.787. This is 1 1/4 stock, yep. So it's going to roughly half the diameter. 50 thousandths first pass. I think we're going to try a different insert. Do a 75 thousandths pass. That's a better finish. And let's speed it up a little. Get that surface feet per minute back up again, like it was on the outside. Yeah, once the feed rate goes down, the surface finish kind of goes to hell in a handbasket. Isn't that lovely? All right, so now I need to take a small section down to 0.591. There's no spec for how long this piece, but I'm guessing like 100 thousandths. So I'm gonna go compare it to the test piece I've got. Alrighty, so we're gonna line these guys up. We're gonna have to go probably a little bit undersized because of the corner radius. So to get a very sharp or very small corner radius, I'm going to use my parting tool to walk this guy in. Yeah, I think We're going to walk from 0.787 to 0.591, and we'll probably go like a thousandth under or something like that. Okay, we should be at 0.6 now. I should go 9 thousandths under this for a proper fit. So I'm going to stop here. I should be 9 thousandths over, and this should not even start. Yeah, it's close. Okay. Oh, that's a dead-on fit. Okay. Wow. All right. Okay. Well, we nailed it. So there's only 50 thousandths of relief sticking over here, but there you go. There's 2 of them sitting on top of it. That's actually a good fit. All right, I'm very happy with that. So next I'm going to part this guy off. They have a very specific length they want it, 1.181 inches or 30 millimeters. So we will do that. And then we will drill and bore the hole in the end to match the mandrel that this thing will sit on top of. I'm going to slow this thing down a little bit. We're just going to part it off. Probably be quicker just take it over the bandsaw and then come back and face it. I think I'll do that, because I have to face it to size anyway, so we'll just part it off on the bandsaw and bring it right back. We're going to be parting with the bandsaw. I don't know if this is mild steel. It's cutting a little bit harder than I would have expected. We're just going to face this other side dimension. I got to take about 212 thousandths off. So we want a flat bottom hole, and we want to go in 0.276, so I've set my 0, and it actually slightly is larger diameter than this, but I figured this is the easiest way to do a flat bottom hole. And I know I've got it in a chuck, never a great idea. It's going to be hard to get right in there, but I'm going to show you. We're going to bore, and we've got to take about 100 thousandths, increase by 100 thousandths approximately. Checking that size. The hole is currently about 0.426, just slightly over. So we are going to go a little bit more. So I think I got it right on, because it went on very, very smoothly, but a little bit tight coming off. Make sure I deburr this. It's really a piston fit too. It doesn't sit flat. Oh, because I got to relieve the inside edge. And I think I need a little more material off. That's tight. Okay. We're going to take an extra thousandths. And we need to relieve the inside, chamfer it a little bit, just so we don't have a burr. And we can deal with any radius on the cutting tool. All right, so the first part's completed. This piece goes on the end, and then these things fit on top, and this whole thing will be held in a chuck to be welded. And the hole through the center of these vary by a couple thousandths each as well. So anyways, that's it for the first part. The next part is a cap to hold cover glass. I've got the drawing upside down here, but the glass fits down on this ledge with an O-ring. The whole thing slides over the piece of equipment with 4 set screws. So pretty straightforward, although measuring these inside gaps are going to be kind of challenging, so I'm not quite sure I'm going to pull that one off. But we're going to give it a shot. New experience is always challenging. Okay, just going to take all the rest, 20 and change thousandths. Okay, I left enough material in case I have to make 2 parts. Always planning for my mistakes. Next up, as you've seen lots of times, we're going to bore out the center. And that starts with a hole, a drill, okay, that should be good. So now we need to bore out the center to the smallest diameter. So we're going to see this. We're going to go for 1.8. So we're going to bore out the whole middle for 1.8. Kind of forgetting myself because drill bits always remove material a lot faster than boring. So we're going to go ahead and drill this out. Apparently that's even too fast in RPM. I slowed it way down, but we're at 1-inch drill bit, so I guess we're going to go for the full. I am taking a 1/2-inch bite. So we're going up to about 1 1/4. Got to zero my tailstock DRO. That was a lot faster than boring, I think. And maybe it wasn't so boring. Kind of makes an ugly finish though. Actually, it's smoother deeper in you go, just kind of rough on the outside. That's interesting. I wonder if all this was scoring from the chips, because these chips are incredibly stiff. I mean, they're thick. They're 1/8-inch sides, so look at that. That's a beefy piece of material there. Got a lot of material removed. Got a positive rake insert here. Switch to a still bigger boring bar. See if I can get better performance. It's actually getting chip wedging between the side of the boring bar and the wall of the part. And that's what was scratching things up. Yeah, there it goes. Yeah, that completely scratches up the surface finish when those chips get stuck. That is so weird. Next, we do something that I've never had really great luck at being accurate at, which is now we're going to go in 0.6 inches at 2.005. Okay, so I made a mistake when I was cutting this out, the center section out for 2 parts, because what I ended up doing is making it really thin rather deep, and it's gonna sit there and ring on me. So what I'm gonna do is I'm gonna wrap some of this vinyl tape around here, and hopefully that'll dampen some of the ringing. And I just got to make sure I don't get it so hot that it melts the tape, because this is going to end up pretty darn thin. We're going for 2.170. We're at 2. We got to take another 170 thousandths off. I may have to slow it down too. kind of high RPM. This might be too much. It's like 40 thousandths. Well, it's not misbehaving yet. I am genuinely surprised. I think the tape is helping a little bit. This is a 50 thousandths depth of cut, bigger than I thought I should take. All right, we are there. Very nice. Now we just got to part this guy off. So the tape seemed to help. It's a very thick vinyl tape, somewhat like electrical tape, but thicker. It's called clean room tape. Just going to part this guy off. Probably should have gone slower RPM. All right, and we're there. Now I can just take this part over to the sanding plate and clean up the bottom, deburr the edge a little bit. Then we got to drill and tap for 4 screw holes. So before we get going on this final step here, I need to drill and tap 4 832 screws approximately 90 degrees apart, not very specific. So in order to find the halfway point, I've got the round part pushed up against my stop here, and I turned the stop up, found my 0 here, and then went in half the diameter, and that's how I got that. And then I'm going in 220 thousandths on this side, and I'm going to drill and tap 832, then I'm going to rotate approximately 90 degrees. Fortunately, there's nothing particular about this. I'm holding it this way rather than this way so that it doesn't deform the circle. And the problem that I saw was, in order to get these exactly 90, I'd have to build a mandrel to hold this that would fit in my like square collet holder, or some way attach this to something that I can put flats on. So rather than, I don't think the customer really cares, and they don't want to really pay for the time it's going to take me to make the tool to do that. So I guess you could put it on the rotary table too, but we're just going to go straight ahead here and get this done. So at this point, you know the drill. It's going to be center drill, drill and tap, and just make sure that looks like it's on top, which it is. Okay. Now I just need to rotate 90. And what I'll do is I'll take this and I'll put it over this guy roughly horizontal. We'll just get this guy roughly horizontal, and that should be right, more or less. Like I said, this is not a precision operation, fortunately. Here's this guy done. So down here goes an O-ring and a piece of cover glass. This whole thing slides over a tube that pushes down on both this ridge and the glass, I'm guessing, and then you tighten the set screws. And that's it. It's a pretty straightforward part. Took some time, about an hour. Thanks for watching. Hope you find it useful. Hope to see you next time.